Check one, check one, check one. Right. Good evening, everyone. Today is a homework discussion session for the grade 10. We'll be discussing motion in straight line questions, right? In the Tute. In the class, I gave you all some homework. At Kotahena class, we discussed it in the class. No, Candy class, I think we discussed it in the class. Other places, we didn't discuss this in the class. So this discussion will be held today through this online, through YouTube and Zoom. After the class, the recording also will be available for you. All right, before we start, tell me, can you all see the board clearly and hear me properly? Yes. Yes. All clear, na? So, YouTube. Yes. Yes. Hard. Right. I already gave you the homework in case if there are any new students. In case if there are any new students who didn't join this session, I have sent the tute to you all. See that you all do the questions, or you can do the question together with me during the discussion. Hurry, we'll start. Take out the homework. Take out the homework. Motion in straight line. Yes. Yes. Hurry. I think the homework that I gave was velocity time graph question 1, question 2, question 3. Mixed exercise. First question we did in the class, or Pythagoras question. This we did in the class. But I will discuss that. This also I'll discuss. Second question and the third question. Those are the homework I gave. Now don't ask me, sir, when will the class finish? I also don't know when will the class finish. The moment we finish all the discussion, I will finish the class. Harid, that's how the class will proceed. I think this is the first online kind of a session for the grade 10. We didn't do online kind of a session for the grade 10. For usually for the O-level batch only these kinds of sessions. I don't know. This is the first online kind of a session for y'all, right? So I also don't know the finishing time. Later on in future also like this, there will be so many sessions for you because now y'all are grade 10. Grade 10 means maximum input of work should be given from your end because y'all are now O-level. Still don't tell I am still grade 10. I have so much of time. No time. Like quickly the time will pass out. Quickly your 2 years will finish off. Quickly the 35 lessons in O-level science will finish off. Quickly your O-level exam will also come. So you can't keep wasting time here. Now you have to work. Hurry, right. Take out, just to start the session, I'll do about first and the second question. And then I have a plan of discussing the what you call the O-level exam question as well. We'll see with the timing and I will discuss. This is your O-level paper. The final O-level paper had a question from motion in straight line. If we have time at the end, we will discuss that as well. Right. Question 1. Velocity versus time graph, displacement versus time graph problems. Question 1. A body with an initial velocity 20 meters per second, initial velocity 20 meters per second, moves under constant deceleration and comes to rest after 5 seconds. So when you read it, you should understand the motion. A body with the initial velocity, that is initial velocity, it seems initial velocity is 20 meters per second, right? Initial velocity is there, there you go. Initial velocity is there. I will write it as u, y. What is the symbol for initial velocity? U. Initial velocity is 20 meters per second. It moves with a deceleration. Deceleration, and now you should think which side the graph will go. Deceleration and comes to rest after 5 seconds. Comes to rest after 5 seconds. Can the final velocity is 0. Why? It comes to rest. In how many seconds? In how many seconds? 5 seconds. Time is 5 seconds, right? Those are the important data. Now, what are they asking? Plot a velocity time graph for this motion, 1, and find the displacement during the 5 seconds. Alright, we'll first plot the velocity time graph for this motion. How to plot a velocity time graph? You draw the y-axis. You draw the y-axis. Y-axis is your velocity axis, and you draw the x-axis. X-axis is your time axis. This is velocity measured in meters per second. This is time measured in second. Right. Now, what are we telling? Object has an initial velocity of 20 meters per second. It already has a velocity, Lamai. What's the velocity? 20 meters per second. Then already it has a velocity of 20 meters per second. It is decelerating and coming to rest. Here you all tell me graph should go up the down the. Graph goes up the down the. I'll allow you all to unmute as well. You can unmute and talk. Graph goes up the down the.
Down.
Down.
Ah.
Down.
Graph goes down.
Down.
I'm allowing you all to unmute. So see that you all have an eye on the mic as well, right? Sometimes your mic will be on, your mother will be coming and scold you, it's scolding you. So whole classroom will hear about it. So have an eye on the mic as well throughout the session. Right. So graph goes down. Graph goes down. It comes to rest now. Graph goes down until the rest point. Until 0 velocity. That is your graph. It's right. Currently, this is deceleration graph. And then they are asking, find the displacement during the 5 seconds. You all tell me, in a velocity time graph, what gives up the displacement? What gives us displacement?
Area.
Area under the graph. Area under the graph will give us displacement. I told you. Velocity time graph, gradient is one step higher, gives us acceleration. Area is one step lower, gives us the displacement. So here VT graph is there. They are asking displacement, which means they are asking the area under the graph. You have to calculate the area under the graph. Displacement is equal to the, I'll write like this. Displacement is equal to the area under the graph. Look at the graph. I'll just redraw the graph. What's the time? 5 seconds. 5 seconds is the time. Look at the graph. This kind of a shape is the graph. What is the perpendicular height here? You should be able to decode it. What's the perpendicular height?
20.
20. What is the base value? What is the base value?
5.
5.
This is a triangle. How do you find the area of a triangle? Half into base into height. That is half into base is 5 multiplied by height is 20. Now do the math there. Half of 20 is 10. 10 into 5 is 50. 50 meters. Got it? Yes. Quickly write down the ones you need. I told you I'll already do the questions, do the homework. If you write, put a tick and keep there. Harani? Harani? Right. I'll go to the next one after every question, Wagi. Like a question like this much. I'll give about 1 minute. You all write it. In case if you need additional types, take a screenshot and keep. Later you can sit and nicely write it. Hurry. Right. Look at the second question. That's the easy question. Nothing big there. Second question. An object starting from rest. Object is starting from rest. Acquires a velocity of 15 meters per second. So from rest, it is acquiring 15 meters per second after moving for 6 seconds. Right. Under uniform acceleration, then the object moves with that velocity for 6 seconds and comes to rest after decelerating for 3 seconds. First, you should understand the motion. What is happening? Now here, 3 motions are taking place. See, an object starting from rest, okay, you're starting from rest, acquires a velocity of 15 meters per second after moving for 6 seconds under uniform acceleration. Harini, from rest to 15 meters per second velocity is gained, which means it is accelerating. We'll write those data separately. Question 2. From rest, initial velocity, rest, object is acquiring a velocity of 15 meters per second. In how many seconds it seems? In 6 seconds, which is acceleration, right? Then, which means motion is continuing. Then the object moves with that velocity. What is that velocity here? 15 meters per second. That velocity for 6 seconds. Then after that, it is moving with that velocity for another 6 seconds, it seems. This is the first part of the motion. Second part of the motion. The object is moving with that velocity. What is that velocity? 15 meters per second. For how many seconds? Another 6 seconds. Right, okay. And still motion is continuing and comes to rest. So at the end, it is coming to rest as well after decelerating for 3 seconds. Then it is coming to rest after decelerating for 3 seconds. Third part of the motion. It is coming to rest. Rest means final velocity 0. From what velocity it is coming to rest? From what velocity? From 15. Because already it is moving at 15. So from 15 meters per second, it is coming to rest in how many seconds? 3 seconds. They are asking you to plot a VT graph for this, velocity time graph for this, right? We'll plot the VT graph. That's your y-axis. That's the x-axis. This is velocity measured in meters per second. This is time measured in second. This is the origin 0. First part of the motion, it is starting from rest, gaining a velocity of 15 in 6 seconds. I'll take this as the 15 meters per second velocity line. So it is accelerating for 6 seconds and gaining the velocity 15, and graph will go in how many seconds? In how many seconds? In 6 seconds. Harini, that's the first part of the motion, that is acceleration. After that, what is happening? It is moving with that velocity, that is 15 meters per second, for another 6 seconds, which means object is moving at a constant velocity. Harini lamai, it is moving with that velocity, that is 15 meters per second, for another 6 seconds, it seems. For another 6 seconds. Here you all think and tell me. Already 6 seconds gone. Another 6 seconds now, what is the time here? Think and answer me.
12. 12.
12 seconds.
That's the second part. Then, third part of the motion. From that velocity, it is coming to rest. It is coming to rest now. Now tell me, graph goes up, the graph goes down.
Down.
Graph goes down.
Down.
And comes to rest, which means graph touches the origin there. In how many seconds? 3 seconds. From 12, another 3 seconds. Now, what's the time there?
15.
15.
15 seconds. That's the graph. This is the acceleration part. These things you don't need to write. I am writing this for you to understand. This is the uniform velocity part. This is deceleration part. Roman 2, find the acceleration during the first 6 seconds. What's the acceleration during first 6 seconds? Now, first 6 second acceleration is there. How to find the acceleration in the first 6 seconds? You know the initial velocity, you know the final velocity, you know the time. Now, you all tell me what's the equation we have for acceleration? What's the equation for acceleration? Acceleration is equal to, help me out.
Final
Change in
velocity.
velocity
Minus initial velocity.
Initial velocity over
over time.
Final velocity is how much? 15 meters per second. Initial velocity is how much? 0. How much of time is taken for this? 6 seconds. That is your acceleration. Acceleration is then 15 minus 0, 15. That is 15 divided by 6. 15 divided by 6 is how much? You can cut it by 3. Then it is 5 over 2. 5 over 2 is 2.5. What is the unit for acceleration? ms to the power minus.
ms to the power minus 2.
ms minus 1.
ms minus 1 is velocity. This is acceleration. Roman 3, what's the displacement during the 6 second? What's the displacement during the 6 second? In this 6 second, what's the displacement? Now tell me, in a VT graph, if there's displacement, what do you calculate?
Area under the
Area graph. So they are asking what's the
Area.
displacement during this 6 second. Now you have to take this 6 second, which means this area. What kind of shape you are getting?
triangle.
Nathan.
Triangle.
So I'll redraw the triangle. You have a triangle there. Tell me the values. What's the base value?
6.
6. Height value. Height value.
15. 50.
Height value 15. Height value 15. So displacement is equal to the area under the graph. Area, triangle area is half into base into height. That is half into base value is 6 into height value is 15. That is 45 meters. Got it? Roman 4, what's the displacement travel under uniform velocity? We'll look at the uniform velocity part. Uniform velocity. That is this part. Uniform velocity. They are asking the displacement during the uniform velocity. Here, what I need to calculate? Area. Area under what? Area under the uniform velocity part. That is this part. Go tell me what kind of shape we get.
A rectangle.
Rectangle. Rectangle. Roman 4. You have a rectangle. What is this value? 12.
6.
This is 6. This is 6. This is 15. This is 6. This is 15. Area under the graph gives us the displacement. That is length into breadth. That is 15 into 6. That is going to be 90 meters. Roman 5. What's the deceleration during the last 3 seconds? What's the deceleration in the last 3 seconds? Right. Could you all tell me, do we have a direct equation to find deceleration?
No.
No. What we can calculate? Acceleration. If we get a negative value for acceleration, it is called as what?
Deceleration.
Deceleration. So I'm going to calculate the acceleration in the last 3 seconds. Acceleration. Initial velocity 15, final velocity 0, time is 3 seconds. I'll do this question and give you all time to write down. Acceleration is final velocity minus initial velocity over time. Now the final velocity is 0. At the end, object is coming to rest. Final 0, initial 15. Final velocity 0 minus initial velocity 15 divided by time is 3. From their acceleration is 0 minus 15 is how much?
Minus 5.
5 minus 5.
3. You'll get the acceleration in ms to the power minus 2. What's the answer? Minus 15 divided by 3 is
Minus 5.
Minus 5.
minus 5 ms to the power minus 2. So you all tell me, if acceleration is minus 5, then what do you call it as?
Deceleration.
Deceleration. So I can write deceleration is equal to the plus value of it plus 5 ms to the power minus 2. Hurry. I'll give about 1 minute. Write down these things. This is my data analysis. This one. Still question is not done. Still question is continuing. Her name. Right. Roman 7, Roman 6. What is the displacement during the last 3 seconds? Now you know the logic. What's the displacement during last 3 seconds? That is this time. During this time, they are asking the displacement, which means you have to calculate the area under that part of the graph. Dingala, tell me, what's the base value there?
3.
3. Height value is?
50.
Then I'll directly write the equations and calculate. I'll directly write the equations and calculate. Roman 7. Displacement is the area. Area is half into base into height there. There the base is 3, height is 15. So if you do the math there, 3 into 15, 45. 45 divided by 2 is 22.5. 22.5 meters. Roman 7. Write down an expression in order to find the total displacement travel by the object during the complete motion using the VT graph. They are asking us an expression. What do you mean by expression? Usually in science, physics question, even in maths, you get the word expression. Write an expression. What do you mean by expression?
An equation?
Equation. What are they asking? Write down an equation. That's the question. To find the total displacement using this VT graph. Without calculating the displacement separately, they are asking you to write a single equation to calculate the total displacement. To calculate total displacement, you need the total area. Look at this whole graph. What is the shape of this graph? Full graph?
Trapezium.
Trapezium. So if I calculate the area of this trapezium, then I can calculate the total displacement. That's the question they are asking. So they are asking us to write a equation to calculate the total displacement, which means they are asking us an equation to find the area of a trapezium. Tell me, what's the equation to find the area of a trapezium?
Half into sum of
Half
parallel
into
sides
sum
into
of
perpendicular
parallel
height.
lines into perpendicular height.
Half into sum of the
Sum of the
parallel
parallel
sides,
sides.
that is A plus B into height. Right? If you want in a side, you can write and keep. What do you mean by A, B values? A is this, B is this, height is that. That is Roman 7. Roman 8, find the total displacement travel using the above expression. Using this expression, they are asking us to calculate the total displacement, right? So total displacement is area of the trapezium. Area, again I'll write half into sum of the parallel side into height, that is equal to half into. What is the sum of the parallel side? Go y'all tell me, what is the value of this length?
6.
What is that?
6.
6.
That is 6. What is the value of this length?
15.
That is 15. What is the value of the perpendicular height?
15.
That's 15.
15. That's also 15. So sum of the parallel side is 6 plus 15. That you multiplied by 15. That is half into 21 into 15. I'm lazy to do this calculation. So what I will do is this. If you want, you do that. Come on. I'm lazy for that. I know the displacement here separately. I know the displacement here separately. I know the displacement there separately. I'll add it. Because I love addition compared to this calculation. Here the displacement we already found. How much? 45 meters. Center part the displacement is 90 meters. Last part the displacement is 22.5. Neither. Last part is 22.5. So if I add it, I should get the answer. That is 0.57. 157.5 meters. The same value you should get when you multiply this as it. How is it? Mhm. Right. I go to the next one. That's your second question. Go into the third one. An object was projected vertically upward at a velocity of 30 meters per second. Right. They're talking about vertical upward displacement. I have analyzed about upward displacement more than 2-3 times in the class. We'll analyze the upward displacement one more time. When you throw an object up, initially you give it a velocity. Harini, this marker pen, this pen, if I want to throw it up, I have to give it a velocity. If I give a velocity only, it will go up. So initially I give a velocity. Then it goes up. So you all tell me, when it goes up, it will accelerate the decelerate the
Decelerate.
Decelerate means the velocity reduces. When the marker pen goes up, this pen goes up, its velocity reduces. Slowly, it will reduce. It won't increase. No, it won't increase. And if it increases, what will happen? It will go up, it will break the ceiling, it will leave the sky, it will leave our planets, and it will go to some other planet. When you throw something up, velocity reduces, which means it decelerates. So it decelerate, and at the maximum height, what's the velocity? We have analyzed these things.
0.
Velocity is
Zero.
0, which means for a millisecond, that object comes to rest. After it comes to rest, then what will happen? Will it again go up? No, it will come
Down.
It will
Down.
come down, downward motion. During downward motion, it will accelerate the decelerate the
Accelerate.
accelerate from rest. Slowly, the
Accelerate.
velocity increase. And finally, it reaches the initial position. What can you tell about the projected velocity and the touchdown velocity?
They are equal.
Both are equal. What can you tell about the time taken to go up and the time taken to come down? Both are
Equal.
equal. Right. So those are things we know. Now we'll read an object was projected vertically upward at a velocity 30. So initial velocity is 30. So you're throwing it with 30. It goes up. It comes down also with 30. Problem 1. Prepare a velocity time data table and graph navy. Data table indicating the variation of the velocity with time from the moment the object was projected until it reaches the maximum height. So until it reaches the maximum height, you prepare a velocity time data table. They're not asking the graph, they are asking a data table. We'll take this as the time value, this as the velocity value, time in seconds, velocity in meters per second, right? Initially, when the time is 0, what is the projected velocity they are telling? What is the projected velocity? 30. So initially, when the time is 0, you are projecting it with 30 meters per second velocity. So initially, velocity is 30. You all tell me, when it is going up, it is decelerating. What is the value of the deceleration? How much is the deceleration?
10.
10 ms to the power minus 2. Why? Because when the object goes up, deceleration will be equal to the gravitational acceleration. Again, I repeat, deceleration will be equal to the gravitational acceleration. But it won't act as acceleration, it will act as a deceleration. What do you mean by 10 ms to the power minus 2? Every 1 second, velocity decreases by 10. That's what you mean by deceleration is 10 ms to the power minus 2. We are discussing this thing very deeply in the class. Deceleration is 10 ms to the power minus 2 means every 1 second velocity decreases by 10. You all tell me 0th second velocity is 30. Then in 1 second velocity become how much?
20.
2 second velocity become
10.
3 second velocity
Zero.
become
0.
Hari nilamai. You're projecting it with 30 meters per second velocity. In 3 seconds, it comes to rest. I have taught you all this logic. If you project with 30, in 3 seconds, it comes to rest, which means in 3 seconds, it reaches the maximum height. You project with 30, in 3 seconds, it reaches maximum height. You project it with 40, in 4 seconds, it reaches maximum height. You project it with 50, in 5 seconds, it reaches the maximum height. Right? So in 3 seconds, it is reaching the maximum height. This is your velocity time data table. Roman 2. Sketch a velocity time graph to describe the motion. They are asking us the velocity time graph to describe the motion. Right. Roman 2. Velocity in meters per second. They are just telling prepare a velocity time graph to describe the motion. They are not telling whether to describe only the upward motion or only the downward motion or the total motion. So best is you mention the total motion there. Actually, what is asked there is the total motion. That is for the object to go up and come down. Go up and come down. Right. First, we'll draw the upward motion graph. Upward motion graph. Initially, you are throwing it with 30 meters per second velocity. So initial velocity is 30 meters per second. You all tell me when the object is going up, it is accelerating the decelerating the
Decelerating.
decelerating. It is decelerating now. Graph goes up the down the
Down.
graph goes down. It goes down, then velocity decrease, and finally at the maximum point, velocity become how much?
0.
Zero.
So at the maximum height, that is in 3 seconds, velocity become 0, which means this is the maximum height. H max. That is the maximum height. Now they are not telling whether to draw the graph only for the upward motion. So better to draw it for the downward motion as well, because they are not telling. They are telling draw the VT graph for the total draw the VT graph for the motion, right? Now we'll draw for the downward motion as well. Upward motion, this has happened. During downward motion, what is going to happen? Now the object is falling down. Object is falling down. Direction of the velocity is changing. Before direction of the velocity is upward, now the direction of the velocity is downward. How to show a change in direction of velocity in a graph? I taught you these things. How to show the change in the direction of the velocity in a graph?
Go to the negative side.
If you take positive side of the graph as one direction, then you can take negative side of the graph as
Negative.
The other direction.
opposite direction. For example, if you take positive side of the graph as the upward motion, then negative side of the graph can be taken as what motion?
Down.
Downward motion.
Down.
So, to draw the downward motion graph, I'm going to take the negative side of the graph, right? Downward motion. What is happening in the downward motion? Acceleration. During downward motion, object is accelerating. From zero, velocity increase. It keeps on increases and it falls down with what velocity?
0.
You're projected with 30 and it again comes down with
30.
30. It took 3 seconds to go up now. It comes down also in
3
3
seconds.
seconds.
3 seconds.
3 seconds.
Right. So it should touch down with 30 meters per second velocity in 3 seconds. So how to draw that? How to draw that in the graph? You continue the graph downward like that. Now the touchdown velocity is going to be
3.
touchdown velocity is going to be 30 meters per second. You projected with 30, that is positive 30. It comes down with 30, that is negative 30. What do you mean by the negative value here? What do you mean by negative here?
Acceleration.
Direction is opposite.
Accelerate.
Here plus 30 කියන්නේ upward motion. Here minus 30 කියන්නේ downward motion. You projected with upward 30 meters per second velocity. It comes down with downward 30 meters per second velocity. Now you all tell me, here the time taken for the upward motion is 3 seconds. Then for the downward motion also, how many seconds will go?
3 seconds.
Another 3 seconds. Then what should be the time
Another
here?
3 seconds.
6
Six.
seconds. That should be 6 seconds. That's your full graph. Alright. Today students are asking for the Tute link. Tute link is there in the what you call channel. Hurry. Roman 3, find the maximum height reached by the object. Take G value as 10 times to the power minus 2 for the convenience of the calculation. They are asking the maximum height, right? Now this is the H max, no lamai. This is the maximum point. What is the maximum height there? Maximum height is the displacement of the object during the upward motion, or the displacement of the object during the downward motion. That is the maximum height value. Again, I repeat, this is the maximum height point. Maximum height value is going to be displacement of the object during the upward motion. That is this displacement, or displacement of the object during the downward motion. You all tell me in a VT graph how to find the displacement of the object?
Area under the VT.
Area under the graph. So they're asking the height, maximum height, which means you find the area under the graph either in the upward motion or in the downward motion. What can you tell about this area, this area? Both will be?
Equal.
Both will be equal. Oi, hari ni lamai. This is 3. This is also 3. This height is 30. This height is also 30. These two angles are vertical opposite angle, which means these two triangles are congruent triangles. If the two triangles are congruent triangle, what can you tell about this area, both will be
Equal.
equal. So you either find this area or you find this area. I'll find this area. Roman 3, area of the graph gives us the maximum height. Area of the graph is half into base into height. That is equal to half into base value is 3. Height value is 30. So if I do the math there, 15 into 3, 45 meters. Correct? Check in right now. Harane? Can you explain the third one again? Hurry. Third one, they're asking the maximum height. What do you mean by maximum height? What do you mean by height of an object? Now let's take this pen is thrown up. Height of this pen is the displacement of the pen. Let's take this pen is thrown up. Height of this pen is the displacement of this pen. How to find the displacement of an object in a VT graph? Displacement of an object is area under the graph. So area under the graph gives us the displacement. That is, this area gives us the displacement. You don't need to calculate both the area. If you calculate both the area, what does that mean? That's the upward motion displacement and downward motion displacement. That is not the height. That's the total distance. If there's a total distance, you find the area here and you find the area here. They are not asking the total distance. They're asking maximum height, which means only one area you find. Those are the 3 questions from that part. Mixed exercise, first question we did in the class, but in case if there are new students here, I'll quickly discuss it for you all. Question 1, Roman 1, explain the difference between distance and displacement. Tell me the differences between distance and displacement. What is distance? Total length of the path of the motion. What is displacement?
Shortest possible linear length
linear
length
between
starting
point and finishing.
Displacement is the shortest possible linear length between the starting point and the finishing point. Distance is the total length of the path of the motion. Displacement is the shortest possible linear length between the starting point and the finishing point. What else we can tell about distance and displacement? Distance depends on
path. The quantity.
Displacement depends on the
Starting point and finishing point.
starting point and the finishing point. So again, I will tell the difference is distance depends on the path. Displacement depends on starting point and finishing point. Tell me what type of quantities are they? Scalar, the vector, the distance is
Scalar.
scalar. Displacement is a
Vector.
Roman 2, the path taken by a child in order to walk from point A to point C is shown in the figure. A to C. A to C. How she is going? How she is going? She is going from A to B, B to C. Right. Question A. What's the total distance traversed by the child? Lamai, what's the total distance here? A to B, 15 meters. B to C, 20 meters. Then altogether how many meters?
35.
35. I'll directly write the answers because it's done in the class itself. What's the displacement of the child? What is displacement? Displacement is the shortest possible linear length between starting point and finishing point. Starting point is A, finishing point is C. Shortest possible linear length is this length. Odd day appa. Length is not given, no. Then can't do the question. Nah, you can find the length there. How to find the length? What's the theorem? Pythagoras theorem. This is a right angle triangle. You use Pythagoras theorem. You can find the length there. I will do that. This is 15. This is 20. We'll find that length. This is 15, this is 20. I'll take this as x. What is Pythagoras theorem telling us? X squared is equal to 15 squared plus 20 squared. That is x squared is equal to 15 squared, 225 plus 20 squared, 400.
400.
That is x squared is equal to 625. X is equal to square root of 625. That is x is equal to how much?
25.
25. 25 meters. That's exactly Pythagoras. So this is 25 meters. See what? See what? If the child walked from A to B, sorry, A to C via B in 5 seconds. Oh, now time is given 5 seconds. Without stopping, find the mean speed. Roman 1 is speed. Find the mean velocity. They're asking the speed, they're asking the velocity. Right. C part, Roman 1, they are asking the speed. Go tell me what's the equation for the speed? Speed is equal
Distance
to
over time.
distance over time. What is the distance she is walking? Total distance?
35.
35 meters. Time they are telling is 5 seconds. When you divide it, you get 7 meters per second. That's the mean speed.
7 meters per second.
Roman 2, they are asking the velocity. Go tell me what's the equation for velocity?
Displacement over time.
Now
over
it is displacement. Displacement over time. What's the displacement we calculated?
25.
25 meters. Time, no change there, 5 seconds. 25 divided by 5 is 5 meters per second. Or that's it. Second question I didn't do neither. Second question. Briefly explain the difference between scalars and vectors. Difference between scalars and vectors. What are the differences between scalars, and vectors? Go tell me. Scalar. Does scalar quantities have a specific direction?
No.
No. No specific direction. No specific direction. What about vector quantities? Does it have a specific direction?
Yes.
Yes. Have a specific direction. That's the only difference. If you want, you can write some example. If you want. Mass, time, distance.
Speed.
Example. They're not asking the example, but I'm writing and keeping. Acceleration. You all write fully. Displacement. Roman 2. Classify the following physical quantities as scalars and vectors. Distance, displacement, speed, and velocity. That we have already done. Scalars. They are given 4. Distance, displacement, velocity, speed. What are the scalars there?
Speed.
Distance, speed.
Distance is a
speed.
scale.
Speed.
Speed is a scale.
Speed.
Velocity. Vector. What are the vectors there?
Displacement and
Displacement and velocity. And velocity.
Displacement.
velocity.
Roman 3. Displacement of an object moving along straight line is given in the figure. Lamai, now be careful. This is where students make mistake. This is displacement time graph. Displacement time graph, they are mentioning how far the object is moving. That kind of a graph. How it can kind of like distance whenever displacement has a difference there. And this is velocity time graph. This is displacement time graph, right? Now, before all the questions that we did were velocity time graph. Now your logic should change. Now displacement time graph. Question A, there's a small alignment mistake in question A. A is starting from here. How far have the object traveled after starting from rest? Now, what do you mean by how far? Distance, the displacement.
Distance.
Distance.
You travel certain how far they're asking the distance. To confirm it, you have the second question. How long has it taken to travel the above distance? Above distance, I think above distance, they're asking the distance, right? We'll find the distance in that part. They are asking how far has the object moved. That means they are asking the total distance here. Analyze the motion here. First of all, analyze this graph and analyze the motion. Here, time is given 0, 1, 2, 3, 4, 5, 6, 7, 8. Here, displacement is given. In 4 seconds, that object is gaining a displacement of 10 meters, and maintaining that or remaining at that 10 meter for another 2 seconds. Towards the end, again coming back to the original position. What kind of motion is this? Analyze the motion. From 0 to 4, displacement is increasing and becoming 10 meters, which means if I show you all the motion is like, let's take, you are here, the object is here. From here, 0, 1, 2, 3, 4. 4 seconds are gone. Now what's the displacement? 10 meters. Then another 2 seconds are going. 5, 6 is the displacement changing? No, displacement not changing means it's at the same position. Object is at rest. Then last 2 seconds, displacement decreasing. Displacement decreasing moving in the forward direction or backward direction?
Backward.
Backward direction. It is moving in backward direction and coming to the original position again. Coming to the original 0 displacement position again in how many seconds? 2 seconds. Last 2 seconds. So from 6 seconds, 7, 8 coming back to the original position. So again, if I show you all the full motion, let's take, I'm starting from here. 0, 1, 2, 3, 4, 5, 6, 7, 8. Again, I repeat, look here. 0, 1, 2, 3, 4, 5, 6, 7, 8. That's the total motion. Okay. Now look at the total distance I'm traveling. 0, 1, 2, 3, 4. How many meters I have traveled?
10 meters.
10 meters. So to go in the forward direction, I'm traveling 10 meters. I'm staying there for 2 seconds. Then again, I'm returning in the backward direction. Right? 5, 4, 5, 6 here. 7, 8, returning back. Again, in the last 2 seconds also, I am traveling how much of distance?
10 meters.
10 meters.
Another 10 meters. Going forward 10 meters. Coming backward 10 meters. Then what's the total distance?
20 meters.
20 meters.
20 meters. Going forward 10 meters. Coming backward 10 meters. Again, look at my full motion. From here, 0, 1, 2, 3, 4. I have traveled 10 meters. 5, 6 here. 7, 8. Another 10 meters. Now total, how much I'm traveling? 20 meters. Going forward 10 meters. Coming backward 10 meters. Total distance is 20 meters. Understood that?
Yes, sir.
Yes. Right. B part. How long has it taken to travel the above distance? What the total time taken?
8 seconds.
8
seconds.
seconds.
C bar, find the maximum velocity of the object during that period. Now we'll first check what are the places it is having a velocity. 0 to 4 seconds, object is moving. Object is moving means it has a certain velocity there. 4 seconds to 6 seconds, object is not moving now. Object is at
Yes.
rest. So there are
Constant speed.
no any velocity. Last 2 seconds, 6 seconds to 8 seconds, coming backwards now again there is a velocity. Velocity is something like speed. So forward direction there's a velocity, backward direction there's a velocity, at rest there is no velocity. So two places we are coming across a velocity. Now you all tell me out of these two, where is it going to have the maximum velocity? If you can analyze, you can tell. If you have saw my motion correctly, you can tell where maximum velocity is there. Where maximum speed is there. First part of the motion, the second part of the motion, the.
Second part.
For those who can't analyze, again look at the motion one more time. I will show that. See, look very carefully. 0, 1, 2, 3, 4, 5, 6, 7, 8. Which part of the motion?
Second.
Second part motion.
Second
Second
part.
part motion is
Second
more
part.
faster. Why? First part motion in 4 seconds, it is traveling 10 meters. Second part of the motion, just in 2 seconds, it is covering that same 10 meters. First part of the motion, 4 seconds to cover 10 meters. Second part of the motion, just 2 seconds to cover 10 meters. Now, where it is moving faster, second part. So, maximum velocity is during this part. During this part. During this part, what's the maximum velocity? Go tell me. During this part, what's the displacement object is traveling? During this part, what's the displacement?
Minus
10 meters.
10
Why? From 10 meters, it is coming to 0 can. It is traveling 10 meters of a displacement. To cover that 10 meters, how much of time is taken during that part?
2 seconds.
8 seconds. 2 seconds.
2
Again, I
seconds.
repeat. This part of the motion, it is traveling 10 meters. 10 meters displacement. To cover that 10 meters, it is taking a time of 2 seconds. So we'll calculate the velocity there. I'll do it in a separate part. Roman 3 C part. Roman 3 C part. Velocity is equal to the displacement over time. It is traveling 10 meters in the backward direction, 10 meters in 2 seconds. Here, what's the velocity? 10 divided by 2, 5 meters per second. Sorry. 5 meters per second. In the mind itself, do and tell me the velocity of this part. In the mind, do. Displacement 10 meters, time is 4 seconds.
2.5.
Here, if you do, you'll get 2.5 meters per second. Here, if you calculate, you get 5 meters per second. Where is maximum velocity? 5. What can you say about the motion during the interval from 4 seconds to 6 seconds? 4 seconds to 6 seconds. What kind of motion? Object at
Rest.
Uniform velocity. Rest.
at rest. E part. Comment on the motion during the interval from 6 seconds to 8 seconds. 6 seconds to 8 seconds, object is moving forward, the backward, the backward, which means it has a velocity.
Backward.
Velocity is backwards. Now tell me, it's a uniform velocity, the non-uniform velocity.
Uniform.
Uniform velocity.
Find it, I have
Uniform.
taught you the trick. If it is a straight, smooth line, it is uniform. So this is a smooth line, that is a uniform velocity. Uniform velocity, but backward. Or you can tell uniform velocity in opposite direction. That's the nature of motion. Hari, got it?
Yes, sir.
Third question. If the velocity of an object varied uniformly from 10 meters per second to 25 meters per second, initial 10 meters per second, final 25 meters per second, during a time interval of 5 seconds, I'll write those important data separately, from 10 to 25 in 5 seconds. From 10 meters per second to 25 meters per second in 5 seconds. Those are the data. Right. What was the acceleration of the body? Simple question. Initial is given, final is given, time is given. How to find the acceleration? What's the equation for acceleration? Acceleration is final velocity minus initial velocity over time.
Over time.
That is final velocity 25 meters per second, initial velocity 10 meters per second. That you divide by the time. Time is 5 seconds. Now do in the mind itself. 25 divided by 10 is how much? 15. 15 divided by 5 is how
15.
much?
3.
3.
3 meters per square second. Sketch the velocity time graph for the above motion and find the distance traveled during the 5 seconds. First, we'll sketch the velocity time graph. Always remember, when you are drawing a graph, you have to mention, you have to write the axis properly. This is the velocity axis, this is the time axis. Those things you have to mention properly, right? This is 0. Now look very carefully. You're starting from what velocity? 10. You're starting from 10. Now tell me, can I start the graph from the origin there?
No.
No. If I start
Ah.
from origin, then I'm telling I'm starting from rest. Am I starting from rest? No. I can't start from there. I'm starting the graph, or I'm starting the motion from 10, slightly above 0. Somewhere from there, somewhere from 10 only, I'm starting the motion. And I'm finishing the motion at 25. I'm finishing at 25. So if I draw the graph, I have to start from 10. I have to start from 10, finish at 25. This kind of a graph only I will get. Can I draw like this? No. If I draw like this, what am I telling? I'm starting from
0.
rest. I'm telling this because so many students make this mistake. So I start from 10, I finish at 25. How much of time is taken? 5 seconds. Time is 5 seconds. That's your graph. Roman 3, the variation of the velocity of a certain another part is there. Find the distance traveled during the 5 seconds. Distance means they're actually asking the displacement here. I have taught you sometimes distance and the displacement can be equal. So distance means they're asking the displacement here, right? VT graph is there. What gives us the displacement in a VT graph?
Area under the
Area under the graph. Look at the area under the graph. What kind of shape we are getting?
trapezium.
Trapezium. I will redraw the trapezium separately so that easy for us to analyze. That is the trapezium. Neither. This part is 10. This part is 25. This part is 5. You might be thinking, so how to calculate this? I will rotate this. When I rotate it, 5 goes there. 5 goes there. 10 comes up. 25 comes down. Alright. Now you can use it's clearly a trapezium. Calculate the area of the trapezium. Area of the trapezium is half into a plus b into height. That is half into 10 plus 25 into height 5. That is equal to half into 35 into 5. How much? 35 into 5. 140 the net. 35, 353, 51 half is 150.
So, let's
87.5. 87.
Right.
So 87.5.
87.5 meters. Hurry. I'm rotating and showing it so that everyone can understand it's at a PCA. You don't need to rotate it. I'm doing all these things for you to understand this question properly. Right? For you to build your thinking pattern. Now in the exam, from here in the mind itself, you should rotate it and find all these things and calculate. Next, a VT graph is given 0 to 6 meters per second, constant velocity, and then rest, right? Find the acceleration of the object during first 6 seconds, find the distance over, right? We'll first analyze the motion. 0 to 6 seconds, graph is going up, which means what is the nature of the motion? 0 to 6 seconds?
Acceleration.
Acceleration. 6 second to 12 second, graph is in the same line, which means what's the nature of motion? At rest way, this is velocity
Uniform
time graph.
velocity.
Velocity time graph. Make a rest way. If it is rest, velocity
Uniform
should be
velocity.
zero.
Address.
If it is rest,
Constant.
velocity should be zero.
Uniform
Velocity zero.
velocity.
Idhula velocity zero illa. So what is that?
Constant.
Distance
Uniform
velocity.
velocity.
Uniform velocity or constant velocity. Last part, graph is going down. Graph is going down means?
Deceleration.
Deceleration.
Remember in displacement time graph only. Displacement time graph only, straight line is rest. In velocity time graph, straight line is uniform velocity. Those things keep in mind. Question A, find the acceleration of the object during the first 6 seconds. Right, look at the first 6 seconds. Initial velocity 0, final velocity 6, time is 6. Apply the equation. Acceleration is equal to final minus initial velocity over time. Final velocity 6, initial velocity 0, time taken is how much? 6 seconds. 6 minus 0, 6. 6 divided by 6 is how much?
1.
1. 6 divided by 6 is 1. ms to the power minus 2. B bar, find the distance traversed by the object during the first 6 seconds, which means they're asking the displacement. During the first 6 seconds, what is the shape of the graph?
Triangle.
Triangle.
Triangle. Base value is how much?
6.
6. Height value is also how much? 6.
18.
So B part, area is equal to half into base into height. That is half into 6 into 6. 36 divided by 2 is 18. 18 meters. C bar. What is the distance traversed by the object at uniform velocity? Uniform velocity. Check the area under the uniform velocity. What kind of shape you are getting?
Square.
Actually, square. Neither.
Yeah.
This value is 6. This value is also 6. It's a square. Area of the square is length square. That is 6 square. That is 36 meters. D bar. Find the deceleration during the last 3 seconds. Last 3 seconds. Last 3 seconds. Initial velocity is 6. Initial, and this is the starting of the last 3 seconds. Starting of the last 3 seconds, initial velocity is 6. What's the final velocity? What's the final velocity? Final velocity?
0.
0.
0.
0.
What is the time there? 12 to 15, what's the time?
3.
3 seconds.
Initial 6, final 0, time is 3. We'll find the acceleration. Negative value of acceleration is deceleration, right? Acceleration is final minus initial over time. That is finally 0, initially 6. Time is 3. 0 minus 6, how much?
-6.
Minus 6 divided by 3 ms to the power minus 2. From there, tell me the acceleration value.
Minus
Minus 2 ms to the power minus 2. If acceleration is negative, you call it what?
Deceleration.
Deceleration. Then deceleration
Deceleration.
is plus 2 ms to the power minus. That's your answer. What is it? Okay. I'll keep the board. Because I'm writing this right down. We have time now. With this, we'll do this year O-level paper. Right? I can last week one O-level paper finished. That is 2024 O-level paper. That only was done in 2025. So 2025 O-level paper, that in 2026. No? That paper had a question from motion in straight line. So essay question 7, A part. I will put it in the channel and the group will do together. You all try to do before me. This is, I'll mention and put 2025/26 OL paper question. I'll put it to the channel. I sent it already. Do before me.
Increased by the entire amount of the tax. Not does not, it does not.
Someone's mic is on mute. That's not coming here. Done. I'm facing error in getting the question to the display.
increase. That is why this is wrong.
Hurry, come on. There's error in getting the question to the display. I will directly discuss it. The question is already sent to the channel. The question is telling values of the velocity of an object obtained by a student from a displacement time graph relating to the motion of that object during 4 seconds indicated in the following table. They are given the motion table. Time is there, velocity value is there, 0, 1, 2, 3, 4. Velocity values are 0, 2, 4, 6, 8. Right. Question 1. Using the data in the table, draw a sketch of the velocity time graph in your answer script. Nothing big. Now look at the question. We did then the question they have given in the final O-level paper. Make a final O-level paper, right? The questions that we did and the question they are giving. Velocity value is there, time value is there, velocity in meters per second. These are important. For these things only you will lose marks. Time measured in seconds. Time is 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Velocities are 0, 2, 4, 0, 2, 4, 6, 8. So if I draw the graph, when time is 0, velocity is 0, okay. When time is 1, velocity 2. When time is 1, velocity 2. When time is 2, velocity 4. When time is 3, velocity 6. When time 4, velocity 8. So if I join all the dots together, I'll get a graph like that. Draw dotted lines and show the velocity and the relevant time as well. Hurry, you all use rulers and draw. Problem 2. Describe how you estimate the acceleration of the object using velocity time graph we have drawn. They are asking how you estimate the acceleration. Are they asking you the acceleration? No, they're asking how you estimate the acceleration. You all tell me in a velocity time graph, what gives us the acceleration? What of the velocity time graph gives us the acceleration?
Change in the velocity.
Gradient. Gradient, you can write gradient of the graph gives acceleration. Roman 3. Using the graph, find the displacement of the object at the end of 4 seconds. In a VT graph, what gives us the displacement? Area of the graph. Area is half into base into height. What is the base value here?
4.
4. Height value here?
8.
8.
That is half into 4 into 8. That is 16 meters. Got it? Alright. That's your final O-level paper. This is your O-level paper question. Any doubts up to there? If everything is clear, give a thumbs up. No reactions are off. No. Put a thumbs up in the chat box. Motion in straight line questions are also done. Currently, we are doing what you call structure of matter lesson in the theory class. That lesson is also going on. Very important lesson. If anyone wanted to join the class, you can join from now onwards. Structure of matter, very important section is going on in the theory classes these days. In Candy, almost structure of matter is also done. Almost done. We are going to start Newton's laws. හරි. එහෙනම් those are the details. With that, I will finish the session then. I'll meet you all back again with another this kind of a session. Right? Until then, keep working. Good night. Bye.
Thank you, sir.
Bye, sir.
Thank you. Bye.
Bye, sir.
Bye, sir.